This is a video about intern project for course DBMS2. My name is Daniar and now I will introduce our database. So in our database is based on grocery shop. It sells basic grocery items, and in our database we have 9 entities which are transferred to ERD. As a team we developed this ERD which has logical connections like one-to-one and one-to-many. My part was to develop and fill data to these two tables. First one is a review. Primary key for review is RID. It stands for review ID. All other attributes are non-primary attributes. And PID is a foreign key for product ID. CID is a foreign key for customer ID. The idea of this table is to user can leave reviews, and reviews are attached to a certain product. The reviews table follows all normal forms. In first normal form, all column names are unique and all values in the table are atomic. Second normal form, there's no partial dependency because all non-key attributes fully depend on primary key. Third normal form, no transitive dependency because all non-key attributes can be only defined by using primary key. It is in BCNF because RID is super key for reviews table. Next is a product ID, where PID is a primary key. It stands for product ID. In this table we can store products that are available and we can buy in a shop. It also follows all normal forms because all values are atomic and column names are unique, and there is no transitive and partial dependency because non-key attributes depend only on primary key. And PID is super key for product table. Category table is developed to remove partial dependency from products table, so we can get product brand and category name by referencing BID as a foreign key. In categories table, BID is the primary key, stands for brand ID, and brand and category name are non-primary. This table also follows all normal forms, and PID is a super key for this table. All these tables can be are filled with data using Macaro. Approximately there are 30 to 50 rows in each table. Data to these tables can be found in our GitHub in tables folder. This was my part for creation and filling data. Next is code part. My job was to create a function that counts number of records. This function is named record count. It accepts a t name as varchar2, which stands for table name, and returns a number. When we execute this function, we can pass a table name and it will be processed in this function. In declaration part, I declared countRec, which later will be returned. In the main part, SQL query select count from, and table name will be replaced by passed value and stored in countRec. Count command will count number of records in this table. Execute immediate is a command to make this query dynamic so that tname is replaced correctly. If this query will remain static, then tname will not replace itself correctly and table not found error will be erased. At the end, return countRec is returned. To test this function, we can use this code. In declaration part, res is a number. In the main part, res is assigned to this function and we pass down the reviews table. This function will count number of records in the review and output record count replacing res by number. As a result, we will get that review table has 100 rows. Next, my part was to create user-defined exception which disallows to enter title of item to be less than 5 characters. To implement this exception, I created a trigger that works before insertion product and declared in declaration part name length as a number, which will later be assigned to length of the name. Product name is a name of the product that is passed during insertion. Too short is a name of exception, which will be defined later. In the main part, prod name is assigned to passed value using insert, and name length use length command to count the length of that name. If statement checks if name length is less than 5. If it's less than 5, it will raise too short exception. And if is used to close this if statement. In exception part, here is the user-defined exception. When this exception raises, it will raise application error minus 20,001, which is defined as user-defined exception, and the text will be like this. So when this exception is raised, insert will not happen, and insert data will be not stored in the table if it doesn't pass this exception. To test this exception, we can insert a test value that has named test, which clearly doesn't pass this exception because it has 4 characters, so this error will be raised. It has a text that was defined earlier in an exception, and this is how user-defined exception works. Also, my job was to create this report that I'm showing right now. This report contains all defined structures like introduction, ER diagram, code part, and normal forms. And that's all things that I did in this project.
The order comes from a warehouse and the suppliers are responsible for delivering it to warehouse, and the supplier has a size to deliver it to a certain warehouse. The warehouse also has a size of capacity. So here is our procedure which does groups. This code is an example of an Oracle PL/SQL stored procedure that retrieves product data from a database and outputs the average price and review for each product grouped by brand ID. Here is a breakdown of what each line does. So the first line creates or replaces a stored procedure called getProduct grouped by BID. This procedure can be called later in the code or by other applications to execute the code inside. So begin keyword starts the procedure's executable section. The for loop is used to iterate over each record in the result set returned by the select statement inside the parentheses. The select statement retrieves data from product table and groups it by the BID column. It calculates the average price and average review for each group using the AVG function. The loop keyword marks the beginning of the code block that will be executed for each record returned by the select statement. Inside the loop, the DBMS output put line function outputs a string to the console containing the brand ID, average price, and average review for each product group. And loop marks the end of the code block executed for each record, and marks the end of the procedure's executable section. In summary, this procedure retrieves product data from the product table and outputs the average price and review for each product grouped by brand ID. The results are output using the DBMS output put line function, which writes data to the console or output buffer.
Hi, my name is Alibek. I'm one of the participants in this project. I would like to show and explain what I did in this project and what parts I did. This is our ARD. We have nine entity: supplier, category, product, stock, review, order info, tracking, payment, and customer. We made the diagram together. Each team member gave a different idea for the diagram. For example, I created the entities payment and tracking. The other entities were created by my teammates. For tracking, the primary key is tracking ID. For payment, the primary key is payment ID. For example, the number of cards was used to pay and how much the customer paid for the item, and all of this tracked. For example, whether the status of the order or payment has been confirmed, whether the order has reached the address. Then normalization takes place. Each team member has done the normalization for their tables. Normalization for the tracking and payments tables. I went through these criteria. First, if one column should only have one value. Second, if a relation is in the second normal form. If and only if it is in the first normal form, all the non-key attributes functionally dependent on the key as a whole but not an its part. And certain if there must be no transitive dependency. Both tables are certain 3NF, because both have a primary key and all other attributes depends on the primary key. For first NF, I can show the tables in Oracle Apex. Each column has only one value. This payment table and this tracking table. After normalization, we started creating tables Oracle Apex. Me, Adilet, and Dias filled the table with data and sent it all to Daniar. At that time, Daniar created tables in Oracle Apps and inserted this data into the table. To facilitate this operation, we created a Telegram group and exchanged the data. This is how our tables for the project came about. After creating the tables in Oracle Apex, we slowly started down the main part of the project. I implemented the row count procedure. I have implemented the procedure for the procedure table. We need to raise the prices of products of certain brands. When I write brand ID and the percentage of price increase, the affected rows will change their price. This is to execute this procedure. We use this code where we set the BID as 1 and the percentage as 5 and it printed. This is the result. At the end of the form, we split the tasks. I made the video, Adilet uploaded the data to Git, Dias made the presentation, Daniar made the report. During the process of making the video, I explained to my teammates how to make the video and what to tell them. Each teammate filmed his part and uploaded it to me. After I all the video combined and uploaded to YouTube. That's it.
of two tables, order info and customer tables. Order info has attributes OID, data info, CID, and PID. And the primary key of order info is the OID, and customer has attributes password, CID, name, address, phone, and email. The primary key is CID. The next is the create of triggers. I create of 3 triggers: order trigger, payment trigger, and supplier trigger. The order trigger. This trigger will show the current number of rows in the order info table, and this line selects the count of the rows in the order info table and stores the result in the row count variable. And this line prints the value of row count to the console using the dbms output line procedure. And the next trigger is a payment trigger. This trigger works after insertion into the table. It should insert new data into the tracking table. Since after the customer pays for goods, a new tracking data should be created. To insert the data into tracking, I created a cursor to find the data from another table. Insert trigger is a supplier trigger. This trigger works when a data is inserted into the supplier table, and if the is the suitable data in the stock table, it updates the data into the stock table. And if there is no such data, then he goes into exception and inserts the data into the stack table. The next part is the GitHub part. First, I create the repository shop and upload the files and folders, exception, function, and procedure tables triggers. Each in these folders has files of these folders. Okay, that's all.